Previous class, so we have discussed examples on difference equation, and today's class also will discuss examples on difference equation. And difference is, so we have discussed examples with condition like y0 y1 is given, or u0 or u1 is given. But in today's example here we don't have any conditions without u0 u1 and without y0 y1, right? So today's first example, solve u suffix n plus 2 minus 3 u suffix n plus 1 plus 2 u suffix n is equal to 1 by using z transform, right? So far we have discussed difference equation with initial conditions. So here we are solving difference equation without initial conditions, without conditions. So that will be the difference, right? So where is first step is taking z transform on both sides. So z transform of u suffix n plus 2 minus 3 z transform of u suffix n plus 1 plus 2 z transform of u n, this is equal to z transform of 1. So we know what is z transform of u suffix n plus 2. So u suffix n plus 2 is z square u of z minus u naught minus u1 divided by z or divided by z. So we can write this as z raised to minus 1. u1 divided by z or z raised to minus 1 minus 3 into z u of z minus u naught plus 2 z transform of un is u of z. So this is by definition. So this is equal to z transform of 1 is z divided by z minus 1, right? Now collect the coefficients of u of z one side, right? So here also u of z term is there. Here also u of z term is there, and here also we have u of z term. So collect the coefficients of u of z terms one side. So here u of z coefficient of this is z square, and here u of z is there. So coefficient of this is minus 3z, and here u of z term is there. Coefficient of this is plus 2. So z square minus 3z plus 2 u of z, right? Minus, collect the coefficient of u naught term. Collect the coefficients of u naught term, right? So take minus u naught. So coefficient of this u naught term is there. Coefficient of this is z square, because minus we have taken outside. Minus u naught we have taken outside, so inside will be z square, and here what we have u naught term is there. So coefficient of this will be what here? Minus 3z. Coefficient of this will be minus 3z. We have taken minus outside, so inside will be minus 3z. So u naught z square minus 3z, and what left here? Left is this, right? So u1 z raised to minus 1 is nothing but what? 1 by z, or u1 by z. u1 z raised to minus 1 is nothing but u1 divided by z. So 1 z get cancels with this, left with u1 z with negative sign, minus u1 z. This is equal to, right hand side will be same as it is, z divided by z minus 1, right? I'll explain it once again. So first you take z transform on both sides of this given difference equation. Then we know what is z transform of u suffix n plus 2, z transform of u suffix n plus 1. So substitute and collect the coefficients of u of z one side, and collect the coefficients of u naught one side, and collect the coefficient of this u1, or only one term we have, so one side. So this is equal to z divided by z minus 1, right? Next, transfer these two, u naught z square minus 3z minus u1 z from LHS to RHS. So we will get here as minus becomes plus. So u naught z square minus 3z minus u1 of z is there. So transferring this side, plus u1 of z, and plus z divided by z minus 1. This is as it is, right? We want u of z. So transfer this z square minus 3z plus 2 from LHS to RHS. Means for each term we need to divide. Why divide? So multiplication comes this side, division. So we need to divide z square minus 3z plus 2 for each term of this RHS, right? So u naught z square minus 3z is there. So divide this z square minus 3z plus 2 plus u1 into z is there, z divided by z square minus 3z plus 2. Each term you need to divide z square minus 3z plus 2, right? And here also plus z divided by z minus 1 z square minus 3z plus 2, right? So I will take this as a p of z and this as a q of z and this as a r of z. So z inverse of u of z is equal to u naught z inverse of u of z. So this is equal to u naught p of z plus z inverse of u of z is equal to u naught z inverse of p of z plus u1 z inverse of q of z plus z inverse of r of z. Take this as equation 1. So we shall find these three. We shall find these three one by one, right? So first consider. So what we have p of z as? This is p of z, this is q of z, and this is r of z, right? So first what we have p of z as? P of z is equal to z square minus 3z divided by z square minus 3z plus 2. Z square minus 3z plus 2. So this is equal to, and see the numerator here. So z is common and take it outside. So we'll get here as z into z minus 3. So z is common for both the term. Z is common for both the terms. Z is common for both the terms. So take it outside. So inside bracket will be z minus 3 and you split this, right? Linear factor. You split this to linear factor, right? So z square minus 3z plus 2 quadratic equation. You split this to linear factors. So find the linear factors for this 2. So we'll get here as z minus 1, z minus 2. Means we can write this z square minus 3z as taking z as common, z into z minus 3 divided by z square minus 3z plus 2 as z minus 1 z minus 2, right? So this is p of z. Take this z from RHS to LHS. So numerator comes this side, denominator. So p of z divided by z is equal to z minus 3 whole divided by z minus 1 z minus 2. So you resolve this by using partial fraction. So consider z minus 3 z minus 1 divided by z minus 1 z minus 2. So we can write this as a divided by z minus 1 plus b divided by z minus 2, right? Now taking LCM and cancelling the denominator both sides RHS and LHS. So we will get here as z minus 1 is there, multiply z minus 2, z minus 2 is there, multiply z minus 1, and cancelling the denominator both sides RHS and LHS. So we'll get here as z minus 3. This is equal to a z minus 2 plus b z minus 1. So by proper substitution of z, we need to find here constants a and b. So first to find a, so make this term as 0. So by substituting z is equal to 1. So substituting z is equal to 1. 1 minus 1 is 0. 0 into something is 0 and we will get the value of a. So put z is equal to 1. So in place of z 1 minus 3 minus 2. This is equal to 1 minus 2 minus 1. Minus 1 into a is minus a and 1 minus 1 is 0. So you'll get this as 0. So minus 2 is equal to minus a. So a is equal to 2. Similarly, put z is equal to 2. By substituting z is equal to 2, so we can make this term as 0, right? So z is equal to 2. So minus 1 is equal to, because 2 minus 1 minus 1. Minus 1 is equal to b. So b is equal to minus 1. So substitute here, right? So p of z divided by z is equal to a is 2 divided by z minus 1 and b is minus 1. So plus into minus is minus 1 divided by z minus 2, right? Now p of z is equal to 2 into multiply this z both terms of this numerator. So denominator comes this side, numerator, right? Both terms you multiply z. So 2 into taking 2 outside, z divided by z minus 1 minus z divided by by z minus 2, right? We want inverse z transform of this p of z. So z inverse of p of z is equal to 2 into z inverse of z divided by z minus 1 minus z inverse of z divided by z minus 2. So these two are in standard form. So we have a standard result. So what is that? Z inverse of z divided by z minus a is a raised to n. So in place of a, what we have here? 1 raised to n. This 2 is as it is, 1 raised to n, minus here in place of a we have a 2 raised to n. So multiply 1 n times, you will get this as 1. So z inverse of p of z is equal to 2 into 1 is 2 minus 2 raised to n. So this is z inverse of p of z. Similarly, you find z inverse of q of z and z inverse of r of z. So first consider q of z is equal to z divided by z minus 1 z minus 2. So write it in standard form. So q of z divided by z, this is equal to 1 divided by z minus 1 z minus 2 by using partial fraction. So you resolve this. So consider z minus 1 z minus 2. So we can write this as c divided by z minus 1 plus d divided by z minus 2, and taking LCM and so cancelling the denominator RHS and LHS. So we will get here as 1 is equal to z minus 1 is there, multiply z minus 2, c into z minus 2 plus d into z minus 2 is there, multiply z minus 1. Now by proper substitution of this z, find c and d. Now substitute z is equal to 1. By substituting z is equal to 1, so this term will be 0. So we will get the value of c. So 1 is equal to 1 minus 2 is minus 1. Minus 1 into c is minus c. So c is equal to minus 1. Similarly, substitute z is equal to 2 in place of z as 2. So you will get this term as 0. 2 minus 1 is 1. 1 into d is d. So 1 is equal to d. D is equal to 1. So substitute. So qz divided by z. This is equal to a is c is minus 1. Minus 1 divided by z minus 1. Plus d is 1 divided by z minus 2. So take this z from LHS to RHS. So this is in denominator, comes this side numerator, means each term you multiply z. So q of z is equal to minus z divided by z minus 1 plus z divided by z minus 2, and take z inverse both sides because we need z inverse of q of z. So z inverse of q of z is equal to this minus outside, z inverse of z divided by z minus 1 plus z inverse of z divided by z minus 2. So a is 1. So a is 1. So we have a standard result. Again we are using this one, z inverse of z divided by z minus a is a raised to n. So in place of a we have a 1. So this minus will be as it is, 1 raised to n plus, and 2 is there, 2 raised to n. Multiply 1 n times, you will get this as 1. Taking positive term as first, so z inverse of q of z is equal to 2 raised to n minus 1. So take this as equation 3 and this as equation 2. Take this as equation 2. Now find r of z, z inverse of r of z. So for that, so we have r of z is equal to z divided by z minus 1 raised to 2 z minus 2. So take this z from RHS to LHS. So you will get here as r of z divided by z is equal to 1 upon z minus 1 raised to 2 into z minus 2, right? So you resolve this by using partial fractions. So we can write this as 1 upon z minus 1 raised to 2 into z minus 2 as e divided by z minus 1 plus f divided by z minus 1 raised to 2 plus g divided by z minus 2, and taking LCM, and we have z minus 1. So LCM is z minus 1 raised to 2 z minus 2, right? So and here z minus 1 term is there. So multiply z minus 1 and z minus 2 term here, and z minus 1 raised to 2 is there, multiply z minus 2, z minus 2 is there, multiply z minus 1, right? So this is equal to taking LCM and cancelling the denominator RHS and LHS. So we will get here as 1 is equal to e into z minus 1 z minus 2 plus f into z minus 2 plus g into z minus 1 raised to 2, because z minus 1 is there, multiply z minus 1 z minus 2, because LCM is z minus 2 z minus 1 raised to 2, and here z minus 1 is there, multiply z minus 2, z minus 2 is there, multiply z minus 1 raised to z minus 1 raised to 2, right? Now by proper substitution of z, we need to find here E, F, G constants. So first you substitute z is equal to 1. So substituting z is equal to 1, these two terms will be 0. In place of z, 1, 1 minus 2 is minus 1. So 1 is equal to minus f, f is equal to minus 1. Similarly, substituting z is equal to 2. So these two are 0. These two are 0. In place of z, 2, 2 minus 1 is 1. 1 square is 1. So 1 is equal to 2g, right? 1 is equal to g, because 2 minus 1 is 1. 1 square is 1 only, right? So this 1 is equal to g. G is equal to 1. Now we want here E. We want here E, right? So for that, to find E, equate the coefficients of z square both sides, right? So equating coefficient of z square both sides, right? RHS and LHS. So we have LHS as 1. We don't have here z square term. So here coefficient of z square in LHS is 0, right? See, observe here. So LHS, we don't have z square term. So we are collecting, or we are equating coefficients of z square. So in LHS, we don't have the z square term. So this is 0, plus in RHS. So z square is possible. Observe this one. So possible here and here, right? So coefficient of this, multiplying these two, so you'll get z square term. So coefficient of this z square is E, right? Here we don't have, plus you expand this z minus 1 raised to 2 like a minus b whole square. Definitely you have z square term. So coefficient of this z square is g, right? Means we'll get here as equating the coefficients of z square. So you'll get 0 is equal to E plus g. We want the value of E. So E is equal to minus g. So we know what is g. G is 1. So E is equal to minus 1. Now we got E as minus 1, F as minus 1, G as 1. So substituting this, so we will get here as R of z divided by z is E is minus 1. Minus 1 divided by z minus 1, and F is minus 1. So minus 1 divided by z minus 1 raised to 2, plus, and G is 1. 1 divided by z minus 2. Again you transfer this z from LHS to RHS. This is in denominator, comes this side numerator. So R of z is equal to minus z, multiply z all the terms, because z we need to multiply for all the terms, right? Minus z divided by z minus 1, minus z divided by z minus 1 raised to 2, plus z divided by z minus 2. Now take z inverse both sides. So z inverse of R of z is equal to minus z inverse of z divided by z minus 1, minus z inverse of z divided by z minus 1 raised to 2, plus z inverse of z divided by z minus 2. So we know z inverse of, z inverse of z divided by z minus a is a raised to n. So a is 1, and this negative sign minus 1 raised to n, minus, and this is z inverse of z divided by z minus 1 raised to 2 is n, right? Minus n, plus, and here a is 2 raised to n. So we will get here as, taking positive term as first, 2 raised to n, multiply 1 n times, you'll get this as 1 only with a negative sign, minus 1 minus n. So this is z inverse of R of z. So substituting, take this as equation 4. So substituting equation 2, equation 3, equation 4 in equation 1. So we will get z inverse of u of z is equal to u naught 2 minus 2 raised to n plus plus u1 2 raised to n minus 1 plus 2 raised to n minus 1 minus n. So this will be the required solution. So substitute or using equation 2, equation 3, equation 4 in equation 1. So u naught into p of z. So p z inverse of p of z. So this is 2 minus 2 raised to n plus u1 into z inverse of q of z. So this is 2 raised to n minus 1 plus z inverse of r of z is 2 raised to n minus 1 minus n. So this will be the required solution. If you want further simplification, so multiply u naught to this and u1 to this, and taking 2 raised to n as common, and so we can write this un as 2 u naught minus u1 minus 1 plus 2 raised to n minus u naught plus u1 plus 1 minus n, and taking this as c1 constant. Anyway, u naught, u1 and 1 are constants. So anyway, taking this as c1 and taking this as c2. So we can write un as c1 plus c2 2 raised to n minus n. So this will be the required solution, and we have c1 is equal to 2 u naught minus u1 minus 1, and c2 is minus u naught plus u1 plus 1. So this will be the required solution. So if you stop here also, no problem. Still they are not asked such type of examples, but it is there in syllabus, so we need to discuss, right? So this will be the first example, and we'll discuss one more and a last example of this Z transform, and today will be the last class for this module 3. So this completes your 18MAT31 syllabus, right? So Monday onwards revision, right? Now next example, solve by using Z transform. Here also conditions are not given, and we have a difference equation here, u suffix n plus 2 minus 5 u suffix n plus 1 minus 6 u suffix n is equal to 2 raised to n. So here conditions are not given, right? Taking Z transform on both sides of this equation. So we know what is Z transform of un plus u suffix n plus 2. So write down. And what is Z transform of u suffix n plus 1? That is also you write down. And Z transform of un is u of z. This is by definition, right? So we will get here as z square u of z minus u naught minus u1 by z, or u1 into z raised to minus 1. No problem, both are same. Minus 5uz u of z minus u naught minus 6 u of z is equal to z divided by z minus 2. Now collect the coefficients of uz one side. So uz coefficient of this z square, uz coefficient of this is minus z, uz coefficient of this is minus 6 of this uz. This is equal to transfer rest thing whatever we have no minus u naught and minus u1 by z. So all these terms, so you send from LHS to RHS. So minus u naught with this z square, because z square is multiplied to all the terms. So minus z square u naught. So minus is there, comes this side. So u naught into z square, right? And here one z get cancels with this. What left here? Z into u1, z into u1 or u1 z minus comes this side plus u1 z, right? Next here we have u naught term, and coefficient of right here we have u naught term. So minus u naught minus 5z will be u naught into 5z, u naught into 5z, that to be plus, right? Taking plus to this side, so minus 5z u naught minus 5z u naught, right? So transferring z square minus z square u naught or u naught z square from LHS to RHS. So plus u naught z square and minus because minus 5z minus u naught will be plus u naught 5z. So comes this side minus 5z u naught plus, and here z square minus u1 of u1 divided by z. 1z get cancels. So minus u1z taking from LHS to RHS plus u1z, means transferring rest terms, means collecting coefficients of uz and transferring the rest terms from LHS to RHS. So we'll get this step, right? Now z square minus 5z minus 6 u of z is equal to z divided by z minus 2, and u naught is common for both the terms, u naught into z square minus 5z plus u1z, right? So here we want u of z is equal to z divided by, so transfer this z square minus 5z minus 6 from LHS to RHS. This is in numerator, comes this side denominator, means for each term you divide z square minus 5z minus 6. So we'll get next step as u of z is equal to z divided by z minus 2 z square minus 5z minus 6 plus u naught z square minus 5z divided by z square minus 5z minus 6 plus u1 z divided by z square minus 5z minus 6. So we'll write this as u of z is equal to p of z plus taking this as p of z, taking this as q of z, and u naught will be as it is, taking this as r of z, and u1 will be as it is. Take this as equation 1 and we'll solve 1 by 1, right? So let p of z is equal to z divided by z minus 2 z square minus 5z minus 6. So take this z to this side, p of z divided by z is equal to 1 divided by z minus 2 z minus 6 z plus 1. So consider this, resolve this by using partial fractions. So consider 1 divided by z minus 2 z minus 6 z plus 1. So we can write this as a divided by z minus 2 plus b divided by z minus 6 plus c divided by z plus 1. So z minus 2 is there, multiply z minus 6 z plus 1. Z minus 6 is there, multiply z minus 2 z plus 1. Z plus 1 is there, multiply z minus 2 z minus 6. Now taking LCM and cancelling the denominator are in RHS and in LHS. So we will get here as 1 is equal to a into z minus 6 z plus 1 plus b into z minus 2 z plus 1 plus c into z minus 2 z minus 6. Now by proper substitution of z, we need to find here a, b, c values. So first put z is equal to 6. By substituting z is equal to 6, a and this c. So these two, first and last term, will get cancels. In place of z 6 minus 2 is 4 and 6 plus 1 is 7. So 1 is equal to 7 into 4 is 28. With this b, when 1 is equal to 28b, we want b is equal to 1 by 28. Now substitute z is equal to minus 1. So substituting z is equal to minus 1. So these two are 0. In place of z, minus 1 minus 2 is minus 3, and minus 1 minus 6 is minus 7. Minus 7 into minus 3 is 21. So 1 is equal to 21c. C is equal to 1 by 21. Next, you substitute z is equal to 2. So substituting z is equal to 2. So these two are 0. So 1 is equal to 2 minus 6. 2 minus 6 is minus 4. 2 plus 1 is 3. So 1 is equal to minus 12a. So a is equal to minus 1 by 12. So substituting this, hence 1 upon z minus 2, z minus 6, z plus 1. This is equal to a is minus 1 by 12, 1 upon z minus 2 plus 1 upon 28, because b is 1 by 28, 1 upon z minus 6 plus 1 upon 21 into 1 upon z plus 1. Now p of z divided by z is minus 1 by 12, 1 upon z minus 2 plus 1 by 28, 1 upon z minus 6 plus 1 by 21, 1 upon z plus 1. So p of z we want, taking this z from LHS to RHS. This is in the denominator, comes this side numerator. So multiply z for each term. So minus 1 by 12 z divided by z minus 2 plus 1 by 28 z divided by z minus 6 plus 1 by 21 z divided by z plus 1. Take this as equation 2. Similarly, consider q of z, z square minus 5z, z square divided by z square minus 5z minus 6, and take z common from the numerator. So z, taking z common, z into z minus 5, and split this into linear factors. So quadratic equation we have z minus 6 z plus 1. So q of z divided by z is z minus 5 divided by z minus 6 z plus 1. So resolve this by using partial fractions. Z minus 5 is divided by Z minus 6, Z plus 1. This equal to D divided by Z minus 6 plus E divided by Z plus 1. So Z minus 5 is equal to, we have Z minus 6 multiply Z plus 1. We have Z plus 1 multiply Z minus 6. And cancelling the denominator both sides, so we'll get here as Z minus 5 is equal to D into Z plus 1 plus E into Z minus 6. Proper substitution of Z, find here D and E. So put D is equal to minus 1. So put Z is equal to minus 1. So this term will be 0 and we will get the value of E. So 1. Minus 1 minus 5 is minus 6. This is equal to, this is 0. E into minus 1 minus 6 is minus 7. So minus 6 is equal to minus 7E. So E is equal to 6 by 7 because minus get cancels both sides. Right. Now put Z is equal to 6. 1 is in place of Z. You substitute 6. 6 minus 5. 6 minus 5 is 1. So this is equal to D. In place of Z, you put 6. 6 plus 1 is 7. And this is 0. 1 is equal to 7D. D is equal to 1 by 7. Hence, Q of Z divided by Z is 1 by 7. 1 divided by Z minus 6 plus 6 by 7, 1 divided by Z plus 1. So we want Q of Z. So transfer this Z from LHS to RHS. Denominator comes this side, numerator 1 divided by Z divided by Z minus 6 plus 6 by 7. 1 divided by 7, Z divided by Z minus 6 plus 6 by 7, Z divided by Z plus 1. Take this as equation 3. Now last one, R of Z. So this is Z divided by Z square minus 5Z minus 6. So this equal to Z divided by Z minus 6, Z plus 1. So splitting this into linear factors. So R of Z divided by Z is 1 divided by Z minus 6, Z plus 1. So resolve this by using partial fractions. So we can write this as F divided by Z minus 6, G divided by Z plus 1, taking LCM and cancelling the denominator both sides. So we'll get here as 1 is equal to F into Z plus 1 plus G into G minus 6. So substitute Z is equal to minus 1. So 1 is equal to, this will be 0. 1 minus 1 minus 6 is minus 7. So 1 is equal to minus 7G. G is equal to minus 1 by 7. Now put Z is equal to 6. So 1 is equal to 7F because 6 plus 7F and this is 0. So 1 is equal to 7F. F is equal to 1 by 7. Now R of Z divided by Z is 1 by 7. 1 divided by Z minus 6 minus 1 by 7. 1 divided by Z plus 1. So we want R of Z. So take this Z from LHS to RHS. So multiply Z both the terms. So R of Z is equal to 1 by 7. Z divided by Z minus 6 minus 1 by 7. Z divided by Z plus 1. Take this as equation 4. So using equation 2, equation 3 and equation 4 in equation 1. So we will get U of Z is equal to minus 1 by 12. Z divided by Z minus 2 plus 1 by 28. Z divided by Z minus 6 plus 1 by 21. Z divided by Z plus 1 plus 1 by 7. Z divided by Z minus 6 plus 6 by 7. Z divided by Z plus 1 plus 1 by 7. Z divided by Z minus 6 minus 1 by 7. Z divided by Z plus 1. So taking Z inverse both sides, Z inverse of U of Z is equal to minus 1 by 12. Z inverse of Z divided by Z minus 2 plus 1 by 28. Z inverse of Z divided by Z minus 6 plus 1 by 21. Z inverse of Z divided by Z plus 1 plus 1 by 7. Z inverse of Z divided by Z minus 6 plus 6 by 7. Z inverse of Z divided by Z plus 1 plus 1 by 7. Z inverse of Z divided by Z minus 6 minus 1 by 7. Z inverse of Z divided by Z plus 1. So we are using the result Z inverse of Z divided by Z minus A is A raised to N. Z inverse of Z divided by Z plus A is minus A raised to N. So using that, so first one minus 1 by 12, 2 raised to N because A is 2 plus 1 by 28, A is 6, so 6 raised to N plus 1 by 21, A is minus 1, so minus 1 raised to N, right? Plus U naught into 1 by 7, 6 raised to N plus 6 by 7 minus 1 raised to N plus 1 by 7, 6 raised to n minus 1 by 7 minus 1 raised to n into u1, right? So this will be the required solution. This will be the required solution. So here u0 is missing here. So from these two terms, so u0 is common and u1 is common for these two terms. So it is missing, right? And here I have written, right? So this completes your Z transform, right? So I'll download it in this.